Hi, folks, welcome back. I hope you're all doing well. If prompting is like the assembly language of large language models, then surely agents are the first high level languages. And the paper we're looking at today tries to present some abstractions that allow us to quickly and easily construct agents to accomplish higher level complex tasks with LLMs. The best motivating example I can think of for agents is, when you go ask an LLM like GPT-4 to write you code for a problem, and you take that code and you run it and it crashes or it throws an error, and you take that same error report and paste it back into ChatGPT, and then it revises its code, and then you take that new code and try to run it, and you repeat that process until you get code that runs. Automating that whole process is what you would have an agent do. So the kinds of things where we iterate our interaction with an LLM in a manual way, you could try to automate them with more autonomous agents. And then the question becomes, well, what kinds of abstractions or conveniences would you need to be able to quickly spin up these agents and manage them? And that's what the authors in this paper are presenting. They present a framework called AutoGen, which presents some high-level abstractions to build these agents that can take input from humans, that can use tools, that can talk to each other and try to accomplish some high-level complex goal. Before we get into the details, let's talk about, well, why would agents even work? What makes us think that they're a useful abstraction? And the authors here point to three properties that we've noticed LLMs having. The first one is that LLMs respond very well to feedback, in that if they give you an imperfect answer and you tell them what's wrong with it, or what kind of answer you'd want them to give, they are pretty good about using that feedback to then provide a better answer. The second big observation is that while LLMs are very general purpose, they respond very well to prompting. So you can prompt an LLM to solve a more specific class of problems. And the third observation is what I like to call the chain of thought observation, which is that LLMs can take a complex task and break it into smaller subtasks and then attack each of those smaller tasks independently. And when you put all of these observations together, you see that, yes, if you were to structure your problem solving as a bunch of specialized agents that are working together, perhaps talking to each other, perhaps even asking humans for input at certain steps, then you have a much better chance of automating or partially automating more complex tasks. Let's quickly look at how AutoGen is structured and what abstractions it provides before getting into some specific examples of problems they're solving. AutoGen is basically a library. It comes with a bunch of pre-configured LLM agents, things like a user proxy, which is just a way to get input from a human, a chat manager, which can coordinate various agents and humans, or an assistant agent that actually goes and makes calls to an LLM. You can, of course, customize a bunch of the behavior of these agents and the way they talk to each other. For example, you can customize how you generate a reply, and you can customize how the replies go back and forth between agents or between agents and humans, and so on. The authors have a bunch of concrete examples in the paper, so I encourage you to read the whole thing. I want to zoom in on two examples. One is math problem solving, and the other one is Q&A with retrieval augmentation. The math solver is structured as basically two agents. You have a student proxy, which is basically the human student, directly chatting with an LLM. And then under certain circumstances, this LLM can reach out to another agent called expert. And this expert agent is basically another LLM set up to provide feedback and judge the answers of this first LLM. So basically, you have an additional layer of feedback and correction. And they found that on a benchmark of some math problems, this setup of two agents got an accuracy of about 70%, whereas vanilla GPT-4 was only about 55% accurate. Now, one of the interesting things this agent setup allows you to do, that it has the flexibility to do, is allow a human to be in this loop. So under certain circumstances, you can pull in a human to provide feedback on an incorrect or insufficient answer. And here's an example where you're trying to find the bisection of two planes in 3D space, where even though the LLM gets the answer wrong on the first try, when you bounce out to a human, the human can give the LLM a hint, and that helps it to get to a correct answer while still saving the human a lot of messy computation. Let's look at a second example. This one is Retrieval Augmented question and answers. And this is again a two-agent setup where the first agent is a standard RAG agent in that you're asking questions about a corpus, and this first agent has broken it up into chunks and done a vector embedding and all the standard stuff you do for RAG. And then the interesting part is that you have an assistant agent. And the job of this assistant agent is to take the original query and the context that this first agent retrieves from the vector database and make a judgment of whether that context is sufficient to answer the question. And if it is not, it replies back saying, I need additional context. And upon getting the feedback that it needs more context, this first RAG agent will go further down the rankings of its matches and try to provide even more context until you have enough to answer your question, or you run out of matches and you answer with, I don't know. Here you can see how the prompts for these agents are set up. The crucial part is this. If you can't answer the question with or without the current context, you should reply update context. So it's doing a check of whether the query is answerable given the context. And this gives them better recall and accuracy than just plain RAG, where you just retrieve one time and try to answer the question with whatever context you found. But the interesting thing is that they found the additional interactivity, and by interactivity I mean the second agent saying that I need more context, did really help, because they found almost 20% of the questions in their benchmark triggering an update context operation. So this is another example of where this kind of iteration and reflection and then updating based on that, this kind of agent behavior improves the final outcome. The paper has a bunch of other pretty interesting examples, so I'd encourage you to check that out. But that was a quick look at a recent paper that presents a framework called AutoGen for writing and structuring agents and collections of agents that use LLMs. I hope you enjoyed that. If you like content like this, please consider subscribing, like the video, and I will see you all next time. Thank you very much.